that's annoying. Okay, well, I'll try and use different color schemes. Okay, guys, I think it's probably time to make a start. Welcome. Thank you very much for coming. It's quite humbling to see quite so many people here. My name is Harry. How are you? Hooray! Hey, okay, testing. Fine. So what do we got here? We've been through and done all the instructions. I've got a few notes here. Can we read any of that? Yep. All right. Fine. So what I wanted to just ask is get a little level for everyone in the room. So can I get you to put your hands up if you've used Selenium before and done that sort of testing? All right, what are you guys doing here? You already obviously know everything. So you're now in charge of helping the person next to you who knows less. All right? What about who's done unit testing before? There you go. In Python? Lots of people have done unit testing before. Like, this is a beginner's class, guys. So, don't be asking for your money back. I always said it was going to be. So you already know a lot of stuff. Again, I'm going to ask you to help the people next to you. And then finally, who has used Django? All right. And who... Okay, so everyone that hasn't put their hands up so far, please put up your hands. Okay. So, I want you guys to make friends with the person next to you and make sure that they're experienced and they can help you out. Because the next thing I want to ask is, this is quite a big room. And in my experience, as soon as you have more than about 20 people, it's very hard to keep up. The way I like to do these tutorials, I like to make sure that absolutely everyone gets it. And that means that we go at the speed of the slowest person. And that's fine. That's not always the same person. It changes around. But the more people there are, the slower the whole class goes. One way of dealing with that is to do a little pair programming. So test-driven development came out of the sort of extreme programming movement, and alongside everything should be testing, those guys said we should also do pair programming for everything. Hands up who doesn't know what pair programming is? Fantastic. Hands up who's never done it? All right, good. Today's going to be a first. Pair programming is amazing. It's like twice as productive or more. And so this is what I like to propose to you. It's not obligatory. But what I'd like to propose to you is, if you guys are okay with it, I'd like you to get together in groups of 2 or possibly 3 and just choose one laptop that you're going to follow through with and do pair programming. And now that doesn't mean that the person with the laptop types all the way through and the other one just watches. I need you guys to swap the laptop from person to person. I need you guys to choose a sane text editor that doesn't freak out the other person. Okay, so don't inflict VI on the person next to you, all right, if they don't know it, or your weird key bindings. So choose a sane text editor, and then just swap keyboards every so often, let the other person have a go. And particularly if you're more experienced, make sure that the person who's less experienced gets to do most of the work, because they'll get most out of it, and you'll get it out of teaching them, out of helping them through their problems. So that's what I'd like to propose. So do you guys think that you'd be up for that? Medium. Okay. All right, so if you guys are all right with that, I'd like you to take a look at the people sitting next to you and decide who you're going to pair with and whose laptop you're going to use. It is for the benefit of the whole class, so if we all do this, we will get through twice as much material. The other thing I should... Oh, come on, guys, shh, wait. The other thing I should say is that all of the stuff that we're going to go through today is available online and for free. So if you're like, oh, it wasn't really my laptop, I didn't really get through it, blah, 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 you can actually go through all of this stuff in your own time. And the fact is that any tutorial, if you learn something in a tutorial and you never practice it afterwards, you might as well have not gone, right? It's not going to go into muscle memory. So after this tutorial, it's all based on my book. By the way, I'm writing a book, which is available online for free, and you can go through that book and follow through it, and we'll go through the 5 chapters today, and there's another 15 or something that you can go through in your own time and really reinforce what you've learned. So if you're like, oh, it wasn't my laptop, I don't feel like I'm learning, you can pick this stuff up later, go through it again, and you'll be able to really consolidate that learning. So, hooray, pair programming, yeah? Yeah, all right. So good. Negotiate with the person next to you, find a laptop, choose whose laptop you're going to use, make sure it's the person's laptop that's got all the software on it, obviously. Choose an editor, make sure you're comfortable with their keyboard, and close the other laptop for now. You can reopen it later, and as we go through, if there's time, you can always switch back to your own laptop and see if you can, just hack it together on your own one. Cool. All right. Isn't everyone lovely? There you go. All right, so you guys here, are there any beginners in this group?
Sort of, kind of, but I don't know.
What? So if, yeah. So whoever's in the most beginnery, make sure you're in a pair. And like, if you want, just go in a 3. And so the way I recommend you do it. Fantastic. All right, that's amazing. Thank you. So we're all paired up. Everyone's knows what laptops they're going to use. I think more or less. And we found out a bit about you guys. So testing. Why would you want to do testing? Oh, what a waste of time. I found out about testing from a book called Dive into Python. Has anyone ever read that? Dive into Python. Yep. 1, 2, 3, 4, 5. A few people. Right, okay. And do you guys remember like chapter 10 or so in Dive into Python, maybe 20, is about unit testing. And he's got like an example with a Roman numeral calculator. Do you remember that? Yeah? Yeah. Like this is quite a common example in testing stuff. Is you go, all right, let me show you how to make a Roman numeral translator. I'm going to translate like I to 1 and I to 2 and so on. And I'm going to do it with test-driven development. I'm going to write the tests first, and then it will make the code easy. And he shows you, look, I'm going to write tests first of all, I should equal 2, blah, 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 before he writes his function. And then he shows how if you write the test first, it helps you to get the code right. And it helps you to always know the code is right, and you can refactor it. And I was like, wow, yeah, no, that sounds really good. Like, it's really convincing. It sounds like something you really should do, you know, like maybe flossing your teeth or something. And then what happened is I got my first project. I had my first real client. They were like deadlines, and I had things to do. And basically, all of my good intentions about testing just went straight out the window. And like from the sort of full height of my 4 weeks of experience as a Python programmer, I thought, you know what? Actually, I'm probably good enough. I don't need tests. I thought it was pretty shit hot. And I was like, yeah, I'll get away with it. I'll be fine. And you know what? I was fine. I was fine at first. Because like at first, it was just a little web-based application with a database behind it, and I had like 1 or 2 pages, and I would add a thing, and I would go to the website and hit F5, and did it work, and click there, and fine. And like a couple of classes and views, and it was Django project, blah, 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 digging along. And like at first, it was fun, and then like the project kind of grew, and it had sort of 3 or 4 pages, and the weeks passed, and I tried to follow good practices that I'd read on the internet, like DRY, don't repeat yourself, and that ended up in like a sort of 6-level deep class hierarchy with diamond inheritance and like multiple overridden methods and like eval functions which you must never use. Basically I just had no idea what was going on anymore, and I was like, I'd make changes to my code sort of fearfully, and I'd go, oh right, I want to like I change this thing here. Oh, but I think that over there depends on it. Wait, no, but I think if I just override the method, then I can change the base classes, construct, and then, oh God, no, it doesn't work. I think it works. And then I'd go to the website and I'd click through and I think it works. And then I'd find like days later that, oh no, actually that thing was broken, but it was days ago that I made the change and I don't know how to go back to it. And like development just became a nightmare, and I was fearful of changing the code, and I couldn't refactor anything, and there was just this monstrosity. And like, it was just painful, right? Like I was in a painful situation. Can anyone relate to that at all? Right. So then I was lucky enough to get a job with a bunch of extreme programming fanatics at a company called Resolver Systems. Has anyone ever heard of Resolver 1? Yes. All right. Which is a Python spreadsheet thing. Ridiculous. And they said, all right, Harry, let's tell you all about test-driven development. It's going to be great. And I was like, oh, good. I was receptive to it. But I say receptive, like I'm quite a contrary person. So by receptive, obviously what I meant was I was going to drag my feet every step of the way, complain about every test, and go, what? We're writing functional tests as well as unit tests? That's ridiculous. Or like, oh, really? Step by step? I mean, come on, can't we skip ahead? And they'd be like, no, Harry, this is how we do it. Come on. No. And like, after weeks and months, I started to see the real benefits in it and the wisdom in it. And so like I've come out of that kind of converted, I guess, and with all the passion of a recent convert, I'm here to evangelize the TDD with you guys. Bring you into the cult. How about that? Good. That's the story. Any questions so far, like about things? Maybe not. There's nothing really to ask questions about. Anyway, have a go. No, good. What I wanted to say was what we're going to do today then. Not too much more waffling. You guys have all got together, chosen a laptop, chosen a pair to program with. Everyone's all comfortable with that, I guess. And so I was just going to say one thing. Like I said earlier on that we go at the speed of the slowest person. What that means is like every so often I'm going to go like tappa, tappa, tappa. Okay, so you guys should do this, right? And then type this, and then you see this. Everyone get that? And like when I say, hey, does everyone get that? Don't just sort of go when what you mean is, all right, just say no. All right, because otherwise I can't tell. And actually, sometimes I'm going to like run around and come and look behind your back and check whether it really does work. I'm going to find out that you weren't there. Don't be embarrassed. Like loads of people are going to get it wrong. Ask the questions, because you know what? If you're the person that asked the question, there's 15 other people in the room that are like, oh, thank goodness he asked or she asked. I was completely stuck. So ask questions, say no if I ask, have you got this? And you're like, no. Okay, no, good. I'll explain it again, or I'll demonstrate it again, or I'll tell you where in the handout to go. So the other thing to do is make sure you have the handout. When I demo and I go through these exercises, every single thing I do is going to be in the handout. So don't worry if like, oh, it's gone off the screen. You'll be able to go through the handout and actually see, all right, what have we done? As you go through the handout, if you have a pen, you probably find it's helpful to sort of mark off how far through you've got, like maybe cross out the bits that you've done. And then you can always tell how far through the handout. What am I talking about? There's no printed handout. Right. Don't use a pen on your screen. That would be silly. Yeah, try and find some way of figuring out how far through you are. Yeah. Fine. And then let's just talk a little bit about the outline of today, and then we'll get to it. So the plan is to go through the first few chapters of my book, which, did I mention that I'm writing a book? Actually, which you can grab online. I've got a few little discount codes, but you don't have to pay for it, but you can if you want to. And if you do want to, I've got a few little discount codes for the book which you can grab. I'll give those out. So we're going to do a to-do list app, and the reason we use a to-do list app is because I have no imagination. It's what everyone uses as their example. And so that's why I'm using 2. The reason it's just quite a nice, simple web application that demonstrates databases and bits and pieces. It's a simple Django project, but we're going to use test-driven development all the way. Like from the very beginning, we're going to have tests for everything. And the content's more or less similar to the Django tutorial. So hands up who's never used Django before. All right. So my plan is for you guys, like this, I should be able to go to a pace that you would more or less understand it. So if you're ever like, oh, I'm a bit confused about this Django concept, do ask. It's OK to ask and say stop. Like hands up who's never programmed in Python before. Good. Like, so if there are any of you guys, I'd be a little bit like, you're just going to have to wing it a bit and ask the person next to you. Fine. So, similar content, expected output. Right, yeah, OK. So the code listings are on the book. Pair programming we've done. And so let's get on and start. So what we're going to do is we're going to start a Django project to build a to-do lists application. So what is the very first thing that I should do? Anyone that's done this sort of thing before, what's the first thing we do for like a new Django project for like a to-do list app? Anyone? Sorry? What? Write a test is the correct answer. Well done. Why couldn't anyone fall for my clever trick question? Curses. Okay. So what do we got here? So I'm in a little fresh folder. We're going to make to-dos or something like that, cd to-dos. So I'm going to make a little file in here called functional tests.py. Doesn't matter where, so you guys should choose a place in your hard disk to work. And we're going to go from Selenium form, from Selenium, import WebDriver, browser equals WebDriver dot Firefox. And then we're going to go browser.get. And so what we're going to say is, what we're going to do is the test we're going to write here is we're going to write a test that takes a real web browser that opens up a copy of our website, which is going to be running on our own little laptop, and it's going to go to its home page and say, right, we're going to use Django, so let's see if we can even just get the Django Hello World running. So we're going to write a test that says, is Django installed and running on our machine, and can we run the Django test server? So we'll go to like HTTP, go on / what is it, localhost, host colon, 8000, that's where Django goes by default. And then we're going to go assert Django in browser.title. Yep. OK, there it is, 4 lines. That is the simplest possible test you can imagine, right? I am just starting Selenium's WebDriver, which is going to open up a real Firefox window. I'm telling that Firefox window to go to localhost, to the local machine on port 8000, and I'm saying, when you've opened that page, is the word Django in the browser title, right? Simplest possible thing. Let's try running it. What do you think will happen? Oops, no, we don't need one now. OK, hey, by the way, I've got this thing in Vim where the color scheme changes randomly every time I start it, so if the colors are ever totally illegible, just let me know and I'll change them. I just go, I can't read that. It's OK. All right, so here we go. Python 3, functional tests. .py. So what will happen? So what you should find is that Firefox pops up a little window, and it bumps in front of the screen like that, and it goes unable to connect because there's nothing running there, and it leaves an annoying window in the way. But the important thing is you'll then see assert Django in browser.title, assertion error. And that, ladies and gentlemen, is our first expected failure. That's our first test and our first expected failure. We're already well on our way to doing test-driven development. How about that? Yeah! All right. OK, so you guys should all do that. Get those 4 lines of code into a file called functionaltest.py and have a screen saying assertion error. Who's already done it? Wow, you guys are keen. Help the people next to you. Go, go, go. All right. Assertion error. Oh, what do we do next? Some people have already like steamed ahead. What we do next then is we run a Django command to, like, who knows the answer to this? What Django command do we run to start a new project? Yeah, okay, great, start project. Let's try it out. So Django admin.py, start project. And we're going to call it, what were we calling it? Superlists. Superlists. And so then, when you've got that, you should get a little tree like this. So what does Django do? When you start a new Django project, you name it something. It's going to be in a folder called, like, for example, our project Superlists. And just to give maximum confusion for you, what Django is then going to do is put a subfolder also called Superlists in there for you for various interesting historical reasons. So then, inside that Superlist folder, we've got some project-wide configurations, so things that apply to your whole project. And that includes like the settings for your whole project, URLs, and then this manage.py, which is like the Django sort of Swiss Army knife. We've got Django, and so manage.py is what we're about to use now, and we're going to use it to run the Django development server. So Django goes, right, well, if you're developing a web application, you probably want to be able to pop it up on your local PC and take a look at it, and Django provides you with a little server to do that with. And so we'll run that with the manage.py, Python 3, manage.py. Okay, I'm in the wrong folder. CG Superlist, Python 3, manage.py, run server. Okay, cool. And so then you'll find that will pop up in this little window here. And then what you want to do is open a separate console window. Yes, sir? Yes. So that is, on this particular platform, the Django admin.py is a little script that's executable, and it installs itself into a scripts folder where you can access them system-wide. That may not be possible on Windows. Are you running Windows, sir? Okay, so if you take a script and it's like it knows it's a Python script, the system knows it's Python, you can make it executable so you can just run it as a command. And in this case, when you install Django, it will put that script somewhere accessible for you. So you'll probably find if you've got Django installed there, try it, DJ, and it will tab complete Django admin.py for you. Oh, okay, so your distribution may have put it without a py. Okay, so that's running there. BG3. Python 3 functional test.py. All right, so the theory is that Django is now running on my computer, and this time, whoa, when it works, I get this, it worked! Oh my god, that's amazing! So Django is actually now running on this computer, and if we close that window, we can go back and look over in the main console, and you'll see that rather than just erroring out with an assertion error, it just says nothing. And that, ladies and gentlemen, is our first passing test. Oh my god! So I'd like you to all get to that stage. Some people are there already. You may well find that if you skip towards the end of the chapter, as we go through, like if I'm running around helping some people and you guys are already miles ahead, take a look. There are some advanced exercises in the handout, so there's no reason for you to be bored or talking about what you did in your holidays. You can just work on new things. So have a look at the advanced exercise if you're already ahead of that. And otherwise, I'd like to get Django installed, run the development server in one console window, and get the test passing in the other console window. Okay. So that's at run server. You forget you have to cd into the superlist folder. That's correct. If you need to run python manage.py, you have to be in the right folder. So at the moment, the folder that you run the functional test from and the folder that you run manage.py run server are like different from each other, right? One's inside the other. In a minute, we're going to move them all into the same folder so everything's simple. Okay. So how are we doing? Is that working? All right. Good, all right, so I've seen everyone's got that. So what do we do next? We've managed to install Django. We've started a project we started a folder for it. We've worked out our first functional test. What's the next thing to do, everyone? We start doing commits to a version control system. Yes, we're serious programmers. We use Git because it's the best. And so that's what you would do. So what do we got here? We're in the to-do folder. We're going to go cd. We're going to move the functional tests into superlists. By the way, be careful at this point. I'm moving this file into the superlist folder. So you may well find if it's still open in your editor later on, you're editing the wrong copy of the file because you've moved it. So close the copy in your editor at this point. All right, so let's see. Now we've just got the superlist folder, cd superlist, ls. All right, so let's do, well, we don't want the database, so we'll go echo db.sqlite3 and to the git ignore. So for anyone that's not used Git, Git's going to keep track of all our files and keep track of part versions of them. There are some files that we just don't care about. We don't want to make them part of our source code, and that includes db.sqlite, which is the database, which we'll use later. So we put that in git ignore, a little file called .gitignore, which tells Git what to ignore. And then we're going to start our repo in here. So there we go, and we're going to go git add dot, and we're going to get st, and then we've got, oh no, what are all these files stupid dunder, Pike files? Those are little compiled Python objects. We don't want them in our source code repository, so we've got to get rid of them. We like to do this sort of git rm -- cached superlist / pine dunder pycache star.pike. Let's try that. And git st. That looks better. And then we'll go echo superlist dunder pycache. So we'll add that to the git ignore as well. So in Python 3, Pike files go into a special folder called pycache. In Python 2, they're just called star.pike, so we can do that as well. Pike. So the git stuff is optional. If you're still catching up with the stuff before, we can skip it. So we git add, git ignore, git st. Okay, fine. So here we are. We've got our git ignore file. We've got our functional tests. And then we've got the basic Django stuff. We're going to do that as our first commit. Git commit. And then what Git will do is it will pop up a new window. Wow, nice colors. This, if you've never used VI before, Git will probably pop up VI, and you'll be screwed. So, so you can either learn how to use VI, which is wonderful, or you can refuse to be involved in a sort of ridiculous throwback to the 1970s, quit it, and change your default editor. But I'll let you do that in your own time. In the meantime, I first commit. And we'll also learn just how to do commits at the command line without using VI. So there we go. Aha. Get st. So we're ready to go. So what's the next thing that we should do? We've started a functional test, but all that it's doing is it's just checking whether we've got Django installed. Obviously, let's move forwards. So what we can use our functional test for is we use it to spell out the functions, the features in our application from the point of view of the user. So what I call functional tests, people will suddenly say, well, that's an acceptance test. Some other people like to use the word end-to-end test or big test. But the point of view is that it's looking at your application from the point of view of the user, and it interacts with it like a user. So that's why we use a real web browser, and we say, look, well, if our user is using our application, it would go onto our website, and it would click on things, and they would be able to achieve certain objectives. So our functional test is for that, for capturing requirements from the point of view of the user. And one way of doing that, or the way that we like to do it at work, is to intersperse our functional test with comments that sort of use, in human terms, what is the user doing, what do they expect to do. So I'm just going to go and copy and paste them here from the handout. You'll see there's a big code block in the handout which we're going to use at this point. A little bit. Okay. Yeah. Okay, so we got something like this. Okay. Now, so the good thing to do is to take a functional test user, you should give them a name, right? That personalizes them. I've called mine Edith. Right, and we're going to say Edith, who is our imaginary user, she comes along to our cool new to-do list app that she's heard about. She's going to go to the home page. And then we're going to spell out what do we want our users to be able to do on our to-do list app homepage. So she notices that the page is all about to-do lists. So remember, we had our assert earlier on that said assert Django is in the browser.title. Well, we're going to change that to say, okay, well, we obviously don't want it to say Django. It should say something about to-do lists. So we're going to say Edith notices that it says something about to-do lists in the title of her web browser. And you can see how all the assertions are from the point of view of the user. They're things that the user could do or see. We're not writing tests from the point of view of the programmer at this point. Like, it's not about code and functions and variables. It's about visible things and interactions people can have with the site. And so we're going to say, all right, well, what can she do next? She can enter a to-do list straight away. We're going to have a little story. So Edith likes fly fishing. And in the art of fly fishing, you can also get into tying your own lures, tying your own ties. You make them with things like peacock feathers. Fascinating. So she's going to go and type buy peacock feathers. That's going to be the first item on her to-do list. And so we're going to say, okay, what does she do? She types an item in. Then when the page refreshes, she expects to see that there's now a to-do list on there, and the first item is what she's just typed in. And then we're going to say she should be able to type in a second thing, and the second thing gets added to her to-do list. And pretty much, if we've got that, we've got a sort of working minimal to-do list application. And maybe at the end here we say, she's going to maybe just hit refresh or something because she's worried that the website is actually just remembering it all in memory or something. She's going to hit refresh and it's still there. So we've proved to ourselves we've got a to-do list app, the user can do what they want, and it's sort of like persistent, so the user knows they can come back to it at a later date. So that's like the sort of minimal test that says, I know, I've got a to-do list app and it's working here. So what I'd like you to do is like copy and paste those bits of code from, so like in general, don't copy and paste. If you type things in manually, you'll learn more because you make typos and you remember those typos forever. In this particular case, feel free to copy and paste. And then we'll see what happens if we run it. So Python 3 functional test.py. Okay, fine. Assertion error. All right, so now our thing that was passing with looking for Django in the browser title is now exploding saying assertion error. Now, this is not a great way of interacting with this test. Like, we look at this and we're saying, well, it'd be nice if rather than just saying assertion error, it actually said, well, I was looking for the word to do, but what the browser title actually was this. Now, we could do that by taking our sort of assert keyword, and you can like sort of add another argument to this, which would pass an error message. And we could say, assert to do in browser.title, comma, browser title was not to do, it was, and then %s, and then but anyway, that's a lot of work. And the other thing we'd like is it's leaving these annoying windows sort of lying around on our desktop that we have to close manually. It would be nice if the test automatically cleaned up after itself, whether it passed or failed. It'd be nice. And I could do that by sort of writing a try except around here with a finally that does browser.quit. But all of these things are things that people who do testing run into all the time. Better error messages, better cleanup, better setup. And so there are testing tools out there, and we're going to use Python's unit test module to help us structure our test. And so the way you do that is we import unit test over here. And then you structure your tests in unit tests into classes, and the classes contain methods, and any method that begins with the word test is going to be a test method, and that gets run. So we're going to have like a class, what did I call it? New visitor. Are you guys following along with the handout here? You can tell me when I get stuck. Yeah, test case. And then I'm going to say, right, I'm going to have a little bit of setup for the test. All right. And I'm going to have a little tear down for the test as well. Test. So then we're going to say, okay, well, let's have our test. Test starting a to-do list. Self. Shoot. Okay. Ching, ching. All right. And okay. So I'm going to change our little browser to a self.browser. I'm going to start it in this special test setup method. I'm going to go through, indent everything, and put it into my test function. And instead of doing assert to do in browser.title, I'm going to go self.assert. Okay, great. I love it when I press F1 in Vim. It sends me to the GNOME help menu. It's really helpful. Yep. Okay. And then we change our sort of assert in to this special self.assertIn method. And finally, we're going to have a tear down. That becomes self.browser. Okay, and then we no longer need that one. And then finally, we have the if dunder name double equals dunder main colon unit test.main Okay. Who knows what this if done to name? Who knows if this if done to name equals done domain? Who knows what that is? Right? Okay, fine. Now, who can explain it to the class? Yes. Yep. So when it's run from the terminal, this will evaluate to true. And dunder, for those people who are not familiar, dunder is a way of saying double underscore. Some people like that. Some people think it's stupid. I like it. So if done to name equals done domain, then we're going to run the actual test. So what's this saying is like, okay, I'm going to define a class. I know that I have setup and teardown. These are special methods that get run before and after each one of your tests. Your tests are any method of that class that starts with the word test. So if there's multiple tests, setup and teardown will get run multiple times before and after each one. So that's a nice way of making sure all your tests are independent from each other and they clean up nicely. And then finally, we're actually going to make our assertions using self.assertin. And then that's just a sort of class. So if I didn't have this bit, that script running it would do nothing. So I say, right, well, if I'm running this, then I call unittest.main, and that's the magic method that goes, right, okay, wait, let me go and find all of the classes that inherit from unittest.testCase, and I'm going to go and run all the setups and teardowns and tests for you. So then now, if we go Python 3 functional test.py, we should get zip, bang. So the window pops up, it disappears immediately, and now the error message, instead of just being assertion error, says, aha, assertion error to do, not found in, welcome to Django. So I've got a much more helpful error message, and I've got cleanup. All right, that's what I'd like you guys to get to. Are there any questions about that? Come on, don't be shy. And there is a prize for the most stupid question of the day, like totally. So like, if you feel like, oh, I can't ask that question, that's stupid, there'll be a prize for it. And like, you will like genuinely, yeah. Mm-hmm. So don't be embarrassed. Mm-hmm. Do-do-do-do. Okay, fine. Fine. All right. So has everyone got that? We've got the little assertion error, I'm sure. So what do we do next? Who's been looking ahead? Come on, guys. Shh. I know that I left you to talk for ages, but like now back. Okay, so what happens next? Who's been like skipping ahead? No, what? You're not? Okay, fine. So what do we do next? Remind me. Okay, so basically we've got this sort of to-do in the flowers.title. We're starting to use the unit test. Oh, the implicitly wait. Yeah, thank you very much. I just wanted to address a question. Did anyone look at the advanced exercise and figure out what add cleanup does? Okay. Can you explain it to the rest of the class?
It allows you to add a function to be run after your test. So teardown would run, but also any of these other functions.
Yeah. Good answer. So we've seen that like the setup function runs before all the tests, and teardown runs after all the tests, and add cleanup is another way of creating a function that's going to run at the end. Now, the reason you might use add cleanup is everything you put in teardown gets run every single time. But like a thing that if I use add cleanup sort of like halfway through my test or near the end, then it's only then that it's going to register that cleanup function. So if my test fails before I call add cleanup, it's not going to bother with that cleanup. So it's a good way of cleaning up resources that you use late in a test. So whereas teardown will just clean everything, we'll run everything in here, if you have resources that get used late on in a test and you only want to clean them up if you get that far through the test, then it gets run. If that doesn't make much sense, don't worry, it gets explained a little bit better in my book, which incidentally, I don't know if I mentioned I'm writing a book, which you can read in your own time. Fine, so moving on, implicitly wait. We're going to use, let's see, so we pop that in here. So what's this all about? Like Selenium, when you like Selenium browses through web pages and you can click stuff and the page refreshes and whatnot, it's quite hard on a web page to figure out whether it's like fully loaded yet. So if you click on a thing and you expect the page to refresh and then a new thing to appear, like if you write a test that says click, is it there? Well, maybe the page hasn't loaded yet. And implicitly wait tells Selenium, okay, well, if I've asked you to find a thing and it's not there, just wait a few seconds for the page to settle down and load. It is not perfect. And when you get into more advanced testing, you're going to want to use something better than that. But for now, this gets us through the next few lessons, the next few chapters. So that's just saying, wait a little while, Selenium, don't get ahead of yourself. What you can actually build is like a proper pattern that like does a little bit of polling on a page and says, has it refreshed yet? Has it refreshed yet? And it's particularly useful for testing JavaScript stuff, which is doing all whizzy things. Right, so browser.implicitly wait. So at that point, you might do a commit. So the next thing we want to do is we actually want to start building our application. So we've now got a good test. It's failing for a sane reason. And we actually want to return a real web page that starts to look like our to-do list app. And so the way we're going to do that is we're going to build an app. So if Django structures like its projects, they're called projects. So a project is equivalent to a website that you're building. And then Django suggests that you use apps to structure your code. And so one project might have many apps. So in our case, we're going to have an app for to-do lists, and later on you might build an app for the sort of authentication and accounts, and you might build an app for, forums, and you might have an app for, payments. So you might have multiple apps, and Django suggests, like the idea is that maybe, like you could use one app that you've made nice and small and coherent for one project, you might actually be able to reuse it in another project. Now, I've never actually done that or seen it done, but I am assured that it's possible. But even if you never do that, it's still useful as a way of structuring your code. Fine, so we've got apps. We can start an app. Who knows what the command is to start an app? That is correct. Python 3, manage.py. So it's another manage.py command, start app. So that tells Django, oh yeah, okay, well done. And we're going to call this one lists. And we'll do treat. So what have we got now? We said start app lists. And what that's done is right next to our test file, it's made a new subfolder called lists. It's in the same folder as manage.py and the sort of superlist subfolder. So we've got superlist/lists, superlist/superlist. Inside lists, we've got models.py, where we can do databasey stuff. We've got views.py. We've got migrations. We've got admin. And of immediate interest to us, there is tests.py. Hooray! So Django is being good there. It's like giving you some sort of placeholders, and it's encouraging us to do some testing. So that's what we'll do next. Let's go and take a look at this new tests file. So tests.py, here it is. It should look something like this. And what we're going to do is, like, we're going to start, so we've made a functional test that tests the application from the point of view of our user. We're going to start now building a unit test. And a unit test tests your code from the point of view of the programmer. And we can use the Django test runner to write our unit tests. And we do similarly, we use a test class like this. So we're going to call class, so like smoke test. Unit test case. All right. And we're just going to make a little test that's going to be like maths. Okay. Plus 1, 3. Ha-ha. All right, we use the Django test case. Okay. So I'm just going to say, all right, well, let's make a test that says 1 plus 1 equals 3. What? That's ridiculous. What's the point? The point is I want to see this test fail to be sure that I know that if I write tests, they get run, and seeing them fail proves to you that your test runner runs your tests. So this is a deliberate mistake sort of thing. And then how do I run my tests? You go python manage.py test. And sure enough, I get a little assertion error there. So that's our little first unit test. It's just a placeholder. So that's where I'd like you to get to. Do your start app lists, get the list folder, get test.py, and build a little test class in there that says 1 plus 1 should equal 3, and see it fail. And so now we've got two commands, one to run functional tests, Python 3 functional test.py, and then another one to run our unit tests, Python 3 manage.py unit tests. So let's get that working, and then we'll write our first unit test and make sure I really explain what the difference is between the two once we've written one and seen one. Okay? Yep. Or I can give it to you on a USB key. Oh, but that's no good to you, is it? You guys okay?
No.
All right. Okay, fine. So there was a question there about like why are we using unit test.test case for the functional tests and we're using Django's test case in the unit tests, like it's a little bit backwards, right? So Django.test.test case inherits from unit test.test case. So everything you can do in unit test case, you can do in Django test case. Django test case comes with a bunch of extra Django-specific tools for testing Django code. So it comes with like stuff for testing views and stuff for testing models and templates, and we get to use it a little bit later on. So that's why we use it for our unit tests, because they need to know more about the code that they're testing. So conversely, the functional tests, they should only know about the user and the website they're looking at. So in a way, the functional tests shouldn't know about Django at all. I should be able to have the same functional tests and change my whole app to using Flask or Web2Py or something, and the functional tests should all still pass. So that's why the functional tests don't use Django stuff. Now, admittedly, later on, we have some functional tests that do use Django stuff for like shortcuts, but that's the theory anyway. Good. So we've now got a way of running sort of Django-y unit tests, and we've got a way of running our functional tests. So let's start writing our first view. So we've got our functional test, which is failing. It's saying, oh, Harry, I want to see to-do lists in my browser title. So the next thing we want to do is start building, like telling Django to give me a web page that says to-do in its browser title. And so the way that Django does that is it does it with these things called view functions. So is anyone familiar with the model view controller pattern? Okay, good. So just for maximum confusion, Django have decided that their controller is going to be called view functions. Models are still models, but the controllers are views, and the views are templates, and there's sort of like not really, but you could maybe imagine a controller. Anyway, whatever, right? So in Django, we have view functions, right? And so like any web server, right? Like a web server's job is to receive a request from a user's browser. Like, look at that request, look, what URL is it for, and what is the request asking me for, and then it should be able to transform that somehow into a response, which is going to be an HTTP response, which is going to contain some HTML usually. So it's going to turn requests into responses, and the mechanism for doing that basically are view functions. A view function takes a request and returns a response. So that's what we're going to write next. So does anyone know how we write view functions? What do we do? Anyone who's used Django before? What do we do? Like where, what? Anything? What? Okay, that's cheating. So anyone that's done Django before, like how do we write view functions? Anyone? Sorry? Exactly, you write a test. That's right, we write a test. So, right, this is test-driven development. The first thing you do always is you write a test. Write a test, see it fail, and then we can implement it. So, where am I here? So here's our little smoke test. Let's transform that into our sort of home page view test. And what I'm going to say is that test home page returns, so basically correct HTML, we'll say. And we're going to turn this test into saying, all right, well, so let's imagine that our view function is going to live in lists.views. I'm going to go import, and like the home page, I'm going to say function is called home page. So I import it over here. I'm going to call it home page, and I'm going to give it a request. Okay, so let's build a request. And we go, request equals an HTTP request. So what we're going to do is we're going to build a request that's going to be the kind of request that the user would send. Okay, we're going to pass it to our view function, and it's going to give us a response, right? And then we're going to say, right, if I give my a request to the home page function, I'm going to expect the response to come back with the sort of right kind of HTML. So what are some things that we would like to see in our response? Well, we're going to say that maybe the response.content, which is the actual HTML content, and we're going to say maybe that should start with, and it should start with HTML, like this, HTML. Ship. All right, so that's the first thing. We're going to say, all right, let's make sure the HTML that we get back starts with the opening HTML tag, right? Then it will be more or less valid HTML, ignoring a few precious little things like dog types, okay? So notice there that I'm using the little b before the string, and that says that those are bytes. So we're using Python 3, so strings are like magical, ethereal things that don't exist in the real world, but an HTTP response is something you have to send physically over a cable to a user's web browser, so that has to contain bytes, like actual ones and zeros. And so this is the bytes representation of the string HTML. So that's what I'm saying, like, okay, so the content's going to start with that, and I'm going to say maybe that it ends with, change till W, ends with, and it should be ending with a close HTML, and then we can say something like, all right, well, in the middle of it, to get my functional test to pass, and we start to see how the functional test will drive what unit tests you write. Now, my functional test wants the browser.title to have to-do in, so I can say, well, that I want maybe an HTML tag looking like this, should it work for that. So I'm going to have title to-do lists. Ship, and title. Okay. In response.content. Okay. All right, so that's my lot. I've got like 3 little assertions. I say, right, what do I want from my HTML? I want it to start with HTML, I want it to end with close HTML, and then somewhere in the middle of it, it should have title is to-do lists. And then if I send that HTML to my web browser, the user will be able to see to-do lists, and so I hope that if I get this unit test passing, then my functional test will pass. All right, so should we try running it, and then find out what syntax errors I've made? Okay! Sure enough, the very first thing that happens is it can't even import the home page functions because I hadn't even written it yet. But that is the TDD thing. You really do write your tests first before you've done anything. So we now get into a thing called the unit test code cycle. Well, that's what I like to call it anyway. And what that is like we alternate between running the tests and then writing the smallest possible amount of code that's going to get the test to pass. Why do we write the smallest amount of code? First of all, it's to really check that our tests are testing what we think they are. And second of all, is to make sure that each piece of code is justified by a failing test. It helps us to make sure we've really got good test coverage. So what is the smallest amount of code that I could write to get our test to pass? Anyone? Let's have a look at that again. Anyone? What? A class homepage in view. Yeah, that would work. What I'm actually going to do, like the absolute minimal thing, in views.py, I'm going to do this. Home page equals none. What? Yeah, but sure enough, that does actually now get my test slightly further on. What? Are you joking? Like my colleagues would actually occasionally do this. I'd be like, what are you doing? And I'm like, no, seriously. This is actually the smallest incremental step you can take. I know this is not what I really want, but the current error is just saying I can't import your thing, so we address just that. Now, I am exaggerating for effect here, okay? But the point of learning test-driven development is it's a little bit like a martial art, right? It's not something that comes easily. I guess, it's not something you do naturally. So this is a little bit like a kata. Have you heard the concept of code katas? Well, I mean, I don't know if I'm using the term correctly, but what we really do is like we're going to practice test-driven development to like the extreme degree when we've got a toy project like this. And so I'm going to go really like the tiniest possible steps. And we practice it when it's easy like this so that when we come across code that is hard and that is hairy and that is important, like some big complicated payments class where if you get your code wrong, you're going to be billing people the wrong amount, for example, right? So if you practice going step by step and making really small checks here, then it will be in muscle memory and you'll feel really comfortable later when you come to do more difficult things. So that's the point of a code kata. Incidentally, if you're learning a martial art, any martial art needs a bad-tempered and unreasonable master. And in testing, the bad-tempered master is the testing goat. Have you ever heard of the testing goat? There you go. You've seen a couple of pictures of the testing goat in your handout. There you go, the testing goat. I like to think of the testing goat as like, you know, like in a cartoon when you get those little like devils and angels pop up on either side of you trying to tell you what to do. Like the testing goat is the little angel that pops up over the shell just with a very niche set of concerns. And it's sort of going, no, test first, yeah. Okay. So that's that. All right, so we're in a unit test code cycle now. And so the thing is, like, this might at least seem like a ridiculously small step, but actually when you get into testing, it's very quick to go test, back to code, test, back to code, test, back to code. And you can get into a flow state like that and absolutely get things done. So let's see if I can just use that sort of thing to drive the development of my view. So I had import error, and I'm now saying none type is not callable. Okay, so how do we make homepage callable? We're going to change it into a view function. So we'll go def homepage, pass. All right, so that's step 2. You should find each of these steps is in your handout, so you'll be able to do them one by one on your own. So now it's saying homepage takes no arguments. Okay, fine. So every single thing that I'm going to write in here is going to be justified by some kind of test failure. So now it takes an argument. Now it's saying none type has no attribute content. So it's saying, all right, fine. I've managed to call your function, but it hasn't actually returned anything. All right, well, fine. And it's saying more than that, like it needs to return something that has the attribute content. So for this thing to like a thing that might have the attribute content is an HTTP response, and you'll be not surprised that if an HTTP request in Django is the class HTTP request, an HTTP response is the class HTTP response. And so we're going to go chip, return HTTP response. Zip. So we return an empty HTTP response, fine. False is not true. Okay, so now it's saying, okay, your response does not start with HTML. Okay, so we'll do that. Chink, chink, HTML, chink, 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 zip. So the HTTP response, you can pass it as its first argument, the HTML that you want to return. Zip. And now it's saying, great, you have got HTML in there, but I'm not finding title is to-do list. So let's we can grab that. You can even copy and paste your stuff from the test results. Ship, ship, Control-Shift-C. FG. Okay. All right, we'll pop that in. Finally, now it says false is not true. It does not end with close HTML. All right, so let's add that in. End HTML. And that's a passing test. Hooray! That is our first passing test, passing unit test, everyone. How about that? Yay! Woohoo! All right, so maybe now the functional test will pass. What do you think, guys? Is the functional test going to pass? Let's find out. Python 3 functional tests. .py, let's have a look. Oh, no, it still says welcome to Django. Why? Does anyone know why? Okay, so we've built a homepage view, but we haven't actually yet told Django what the homepage view is going to be in charge of. And so what I said earlier, so we've got view functions that are in charge of turning requests into responses, but the other thing that a web server has to do is look at what URL a request comes in for and decide to do different things based on different URLs. So in Django, you say, right, you assign view functions to particular URLs, like you make a URL mapping between a URL and a view function in a file called urls.py that you might have seen out of the corner of your eye earlier. So we go into urls.py, and you'll see that Django's got some helpful comments in there. Oh, yeah, thanks. Obviously, still got the run server running in the background there. And so by default, it's going to, this little thing, so view functions, the URL mappings are defined in terms of regular expressions. So who is not familiar with regular expressions? Everyone knows regular expressions. Oh, my God, you guys are like, all the people who are beginners, you are not beginners, all right? You are legends if you know regular expressions. So, $, it says, like, this is the empty URL, the empty URL for nothing, so this is basically the root of our web page, and it's saying, okay, well, what do I map that to? And it's saying, so now what we do is we give it a sort of dot notation version of the view. You can actually import the view function directly into here, but the simplest way of doing it is just to change that into lists.views.home. Okay, let me just go and quit whatever it is that's making all that noise in my terminal. Okay, that's better. Page. Fine. So now I've wired up the base URL to the homepage function with a bit of luck. We can try again. Finish the test. Ha-ha! All right, so it got through. It got past the assertion error. It can find the title in, and it's now got to the end. Does that all feel a little bit magic and unreal, like it's not really true? Well, if that's the case, you can actually manually, if you want to, go and open the website on your own computer, go to localhost:8000, and go and take a look at what your home page actually does. And sure enough, you should find it says to-do lists on a totally blank page. And we'll pat ourselves on the back because that is real. Okay. So that is it. That was a unit test code cycle. We drove all of the code in our application step by step using unit tests. So before I let you carry on with this, I just want to say, well, no, okay, let's let you carry on with that. Let's try and get that done. So if you get to this stage where you've got the functional test getting to the end and the little fail that says finish the test, that's where you should get to. Get your view function working, get it returning the correct HTML, get the 3 assertions passing your unit test. Make sure you go step by step. The testing goat is watching you. If you skip steps ahead, then you get negative testing goat points. that's running as the user. We've got some unit tests that test the actual internals of Django. I just wanted to spend a couple of seconds talking about like why we have those two types of tests and how they're different. There was also an excellent question over here somewhere. What was the excellent question? Does anyone remember? Like the guy who asked the excellent question is gone. But it was an excellent question, and it was about, what about the self.fail? Good. So when you get to the end of this section, it should say this, sort of self.fail, finish this test. And also, why is that? The reason is that we're sort of halfway through, right, where's our functional test here? When you're writing a functional test like this, you sort of might spell out a whole story, but you might not get to the end of it. You're like, well, why don't I just get through the first section of the functional test and just see if I can get that far, rather than specking out the whole thing, because you might change your mind halfway through a functional test about exactly what you want things to do. So what that little self.fail there at the end is it's just a little reminder that we're not finished. So that's just saying, okay, well, if I ever get through to the end of this test, I know it's not finished. This is my little self.fail always fails no matter what. So that's just a little reminder that we should finish the test. So then just unit tests and functional tests. Like, there was somebody asking over there, like, why have you got these sort of two types of tests? And the idea is that they serve different purposes. So the functional test is there to give you confidence that from the point of view of the user, your application really works. Like you saw earlier how I made my view function, and I write unit tests for it that say, okay, well, my view should have like some HTML, and it should have title in it and blah, and the unit tests are all passing. And so fine, I had a great function that worked, but when I ran the functional test, it failed because I hadn't yet done urls.py. So the functional test is the thing that really checks that everything is glued together and you've done it all properly. And it's the only thing that can give you confidence that really, for real, your application does work. Now, so that's the thing that tells you it does work, and it works from the point of view of the user, and hopefully it'll help you to design your application from a user-centric point of view. By forcing yourself to write things out as user stories, maybe you're going to design your app like a user rather than designing it like a programmer, or for a user rather than for a programmer. So then what are the unit tests for? They're more about looking at your code, like the individual blocks and modules of your code, from the point of view of the programmer. And the unit tests can also help you get things correct. They're useful for, say, if you've got a complicated function, you might write a lot of unit tests that check all the possible edge cases, like what if I pass in none, or what if it's an empty list, or what if it's a really long list, or all those sort of little edge cases. You can spend some time in unit tests. But the other main point of the unit test is it forces you to think about your code before you write it. So in our view function, we could just dive in and write a view function, right? But if I'm forced to write a unit test first, it forces me to stop and think about my code from the outside. Think about it in terms of inputs and outputs. And think about maybe its API. When I write a test for something, I have to use it like it's going to be used by the rest of my code base. So it forces you to think of your code from the outside, from the point of view of its API. And maybe it helps you to design better code because you're thinking about what it'll be, how it's used, rather than just writing it from the inside out. So that's the answer there. Your functional tests are testing from the point of view of your user. They give you the ultimate reassurance that everything works. And then your unit tests help you to get your logic correct at the individual level. And then hopefully they'll also drive good code design. So good. That's the story about functional tests and unit tests. And we've now got a minimal Django application that sort of returns a bit of HTML. Question? The functional test. So exactly like I've done it now, when you're developing an application, you'll have a bunch of functional tests, and you go, right, let's write a new thing. We'll start by writing a functional test that says, right, well, what new feature? How will the user use it? How can I test? How can I, once it's ready, what will it look like? And that forces you to think through that new feature as the user. And once you've spelled that out, you move in and you start writing the individual unit tests that you need to get that functional test to pass. So there's a little diagram, if you scroll through the handout, which sort of shows the TDD process, which is write a test, see it fail, write the minimal code, run it again, write the minimal code, run it again. And then maybe once you've got it all passing, you might refactor. Okay, well, everything passes, now let me just change the implementation slightly. So that's how you do unit testing. And then so functional testing is the same thing at a larger level. Write a functional test, see it fail. Okay, once it's failing, write some unit tests, see them fail, write some unit tests, see them fail, run some unit tests, see them fail, run the functional test again, and maybe it gets a little bit further on. So the functional tests are kind of like a big loop on the outside, and the unit tests are like little individual loops on the inside. Good question. Any other questions? All right, yes, sir.
What do you think about the structured functional tests like BDD?
Yeah, so I've never used them, but they look really cool. So the BDD, for anyone that doesn't know, BDD is a sort of a way of structuring your functional tests and writing them with a sort of domain-specific language. as so in almost human readable terms. And like, there's always this theory that maybe you're going to be able to get the business to write the functional tests for you. Never happens, right? But maybe by having those tools, it helps you to structure your tests. And they look good. I've just never used them. Good question. Anybody else? All right, fine. So look, it's 22:11. This session is due to finish at about 12:15, somewhere between those times. So this is about the halfway point. Would you like guys to have a break? And please come back here at 5 to 11. Cool. Thanks very much. Let's just leave that on. Fine. Let's check it out. Oh, here we go. Fools! You all came back! I'm not used to hearing my voice quite this well amplified. I'm enjoying it a little too much. Okay, yeah, there was a good question earlier on. Hey, what's that weird traceback where like the implicitly wait thing is all broken and like we're very confused? And I was like, oh, that's because I was an idiot and I put implicitly wait in the teardown instead of the setup. So I sure wish that someone had asked that question at the time. I don't mind looking like an idiot whether it's earlier or later, but the earlier we do it, the less confused people are. So here we are, yeah, okay, implicitly wait obviously is something you do in the setup. You want to tell the browser from the start of the test onwards, let's make our implicit wait 3 seconds. So where did we get to? Yeah, all right, well, so we've got a web page that sort of has a little to-do list, like sort of in its title, and we want to sort of proceed with our functional test and start fleshing out our app and see if we can't actually get a thing that looks like it's starting to be a to-do list app. So we're at the end of, in my book, which I'm not sure if I mentioned, but I'm actually writing a book about testing. It's basically finished, and you can totally read it for free online. It's at www.obeythetestinggoat.com. Like 100% free, don't have to pay for it. I don't begrudge people that read it for free. You can also pay for it if you want, and if you want, they've got some little discount cards. Look, they look like this. They've got a picture of the goat on them. And like these right here, they will give you a special code that you can type in through the O'Reilly website to get 50% off the book. And that special code, I don't think I'm supposed to say this, but I think it's probably valid on any book in the O'Reilly web store forever. So these are worth something. Stupid publishers. No, I love them. Oh gosh, how could I say that? I love my publishers. Right, okay, so we've built a thing. So we're in chapter 3 of my book. So we've got so far is we've built a little view. Next, what we're going to do is do a bit of refactoring. Refactoring. Then once we've done that, we're going to refactor it. We can start using templates. So there was a person asking earlier, God, are we really like returning HTML from a view function? That doesn't sound very much like the MVC pattern. Very good question. So we're going to try and move more towards an MVC pattern where we have like view functions that are separate from the templates, the sort of presentation HTML side. So we're going to do that, and then we're going to move on to starting to save the user request. So when a user sends us like a new item to add to the to-do list, we're going to want to save that somehow and display it back to the user. We're going to go through a process where we're going to start by building an app that can have a list with exactly one item, and then we're going to build an app that can have a list with any number of items, but it's the same list for the entire world. And then we're going to move on to having an app which actually has multiple lists for multiple users, step by step. Good. So that's the plan. Are there any questions then? Did you like digest over the break and think, gosh, why is that implicitly wait traceback happening, for example? Or any other useful questions that are going to help educate the whole class? Anything? No, stupid questions. Remember, there are prizes for the stupid questions, like 50% off O'Reilly ebooks for life, right? There you go. Now someone's motivated.
Would it change the URL UI file?
Yeah.
Restart the server?
No. That is not a stupid question. That's a good question, but you still get a voucher. Here you go. Dun, dun, dun. See, pets win prizes. What? That's a weird thing to say. Okay, so So the question is, right? Why when we did we changed the URLs.side, but we didn't restart run server. So in theory, the little run server process that's running in a separate console window is smart, and it auto detects when you make changes to your code, and it automatically reloads itself. Actually, if you're on Linux and you install a thing called PyINotify, it gets even smarter about how quickly it notices your code changes. Later in the book, we move towards using like a special magical Django version of the server that automatically starts itself up with each test run and sort of clears itself down. So yeah, run server will just keep going. Occasionally you might find that your tests aren't passing, you can't figure out why. If you go off and kill the run server process and start a new fresh one, it might run again. So it might have just got its knickers in a twist. Right, so let's start fleshing out our functional tests. So we've got okay, fine, we've got the bare minimum, which is that Edith can see the site is about to-do list. Let's start making a functional test that actually has Edith go to the website, log in, try and input some to-do items, and sort of see them appearing in on the page there. So I'm not going to type that all out manually. Let's see, where are we? All right, so let's have a look at this here. Okay. Yep. All right. So we've checked that the page title mentions to-do list. And so now let's also do checking that maybe there's a little bit of a header in there. So like, we're going to start to learn to use some of the other Selenium helper functions, the things that Selenium gives you to sort of grovel around in a page and make assertions about what's visible on that page. So here's an example, self.browser.findElement by tag name h1. And what that's saying is like, Selenium says, oh, go to the web page and find an h1 tag, like an HTML, like the part of the web page that looks like a header. And then we're going to assert that the header also says that it's about to-do lists, because like the window title is not a very visible thing. All right, and so then the next thing we're going to do is we're going to go and find an input box, right? And we're going to say, okay, well, Edith spots that there's a text input box on the page. And the way I'm finding that, I've done find element by tag name. Just to show a different one, we're going to do find element by ID. So that's an HTML ID. The ID equals attribute that you have in an HTML element. They're a good way of like fixing particular elements on a page. So we're going to say, oh, we expect it to be called ID new item. And then the other thing is like, so we're testing from the point of view of the user. So little UI things like, you know when you get an input box and it has a little bit of gray text, which is like a helper text saying, oh, you know, you should type this in here. So that's the placeholder attribute. And so we can actually make assertions not just on, like self.browser is a selenium.webdriver class, and it has all sorts of helper methods and functions for like getting URLs and looking at the page. But then the self.browser.findElement.id returns an object which is of class webElement, which represents an element on the page. And then you can do subqueries on elements. So you've got a div, it might contain a sort of ordered list, and you can iterate through them. So you can look through things in a page, you can look through things in an element, you can look at the attributes and properties of elements as well. Okay, so she's invited to do this item straight away, and so like if she's going to type by Firefox, so you can make assertions about the properties of an object, but you can also do things to it. And one of the most important things you might want to do to a web page is type something into it, and so you get this send keys method on the object which says, right, I'm going to send the following key, so I'm going to be like the user actually typing into this. In old versions of Selenium, this was a bit broken. Like there was a way of sending keys to the object, and the way Selenium did it was it would like inject JavaScript into the page and send those key presses using JavaScript. But it would never work properly because like it would send the keys, but it wouldn't also fire off all the JavaScript events, right? So you know when you have, like if you have a web page and you put some JavaScript on that says, oh, listen for when the key press happens, well, Selenium wouldn't quite fire off those. So like so you'd have to type the stuff and also trigger the events associated with it, and you know, it was just broken. The new version of Selenium is wonderful. Like it really is, like when you type into a thing, it really is like a human typing in. All the JavaScript will work, and it will actually happen. So we send some keys, and you can just send it a string. So we're going to say like, by peacock feathers. Fetches? Oh dear. Send keys by peacock feathers. And then I think I've got like input box, send keys. And I think I've used keys.enter, isn't there? So, okay. Now, someone remind me where I have to import that from. You guys looking at the handout? Selenium. Common.keys. Thank you. Yep. Okay. Cool. Yep. Thank you. Thank you. God, I had a total. Anyway, fine. Okay, cool. And so then we're going to say, oh, okay, well, when the page updates, you know, we expect to be able to see a new element on there. Let's see. We're only at chapter 4 now. We'll grab this lot here. Okay. All right, fine. So what is the next thing we're going to do? And then this is a slightly different one. We're going to go and say, right, well, once she hits enter, right, so you type into a box, you hit enter, the page refreshes. It's a normal form submission. And then we're going to go and find the table. We expect there to be a table which is going to have a to-do list item in it. And then we're going to go and find the rows inside the table. So you can see I'm doing a subquery on an object. Now also notice this. This says find elements by tag name, whereas above it said find element by tag name. It's a very common typo. One of them will return one element and explode if it can't find it. The other one will return a list of elements and just return the empty list if it can't find any. And that is a confusing error message to have. And then the next thing is I do, right, so I've got all the rows in my table, and I want to say, right, at least one of the rows in the table should say by peacock feathers. And here's like a beautiful piece of, or like some fun idiomatic Python. Has anyone ever seen the any function? Well, so what's happening in here is a generator, and so that's saying, let's say that any of the rows text, so one of the rows text should be by peacock feathers for all the row in the row. So that's saying like at least one row should say by peacock feathers. And the any function, I almost don't have to explain it because that's how wonderful Python is. But it basically says it takes a list of items or an iterable, and it will return true if any of them are true, and it will return false if they're all false. So there you go. I felt quite smart when I wrote this little bit of code. I was like, ooh, yeah, oh, cool. And you know, that is a warning sign, as we'll see later. If you're feeling smug and contented about a bit of code, right, that's probably a sign that you're being an idiot. Fine, good. So I think we can get about as far as that. So let's see if we rerun that test now. We should get popped up to-do lists. And you notice it waited about 3 seconds. And then it will sort of crash out like this. Now, Selenium tracebacks are a little bit ugly, right? And I haven't really talked about reading tracebacks. But because in testing, we do spend a lot of time looking at tracebacks. So I think in the handout at this point, there's some little call-outs. I can't quite demonstrate it all here. But when you're looking at a big traceback and you're like trying to figure out what's going on, there's sort of several steps to what you must do. And the first step is take a look at your failure and make sure it's the test you think it is. All right, so that's step one. Is like you might get a failure and you were working on a test and it explodes. And you're like, all right, okay, I think I know what's going on. But maybe you don't. Like maybe it's not the test that you think failed that failed. So at first, double check that it really is that fail. So we go and look at this. We see, right, it is my functional test. It's failing in the right method. And the next thing you think is go and look at the error message. So the error message is actually this one here. And it's saying selenium.commons.exceptions.no such element exception. And it's saying unable to locate element method by tag name selector h1. So that's Selenium saying I can't find an element h1 on the page. And then just to make sure, I can like run back up through the traceback until I find a line of my own code. So this is all Selenium, WebDriver, and then up here there. You guys can probably see this on your own PCs. It'll actually say that's actually coming from functional_test.py. So now I've seen, okay, I've seen the line of my own test code that's caused the failure. I've understood the failure message. I know which test is failing. I'd probably figure out what's wrong. If we were running a unit test, we might even have some of our own code in the traceback. So if we had a failing view test, we would see an error message. We would see like where in our tests we called like assert something and it fails. And then we would also see it going into views.py and some code that we wrote. So that would be the final step to check like what in our own code is wrong or where's the error coming from. Good, but this is telling us, right, there's no h1 on the page, and so the next step basically is to go and start adding a sort of header element to our page. And I could do this in here, couldn't I? I could start like going, all right, well, let's add a sort of h1 in there like this and blah, blah, blah. But editing HTML as a long string in Python is a crap way of editing HTML, right? It would be much better if this was in a file called something.html and it had HTML syntax highlighting and so on and so forth. So what we'd rather do is, like, rather than using strings, we can move on to using templates. So yes, of course, Django has a way of giving you a saner way of doing HTML templates. We talked about the model view controller side of things. So if view functions are kind of the controlling logic, templates in Django, which are sort of HTML files that Django can send to the user, are the presentation layer, the views. Yes, I know it's confusing. So the presentation layer, the template. So let's transform this view function from using a string to using templates. And what that is doing, like, so I'm just going to do that, and that is basically refactoring. So who knows what refactoring is? Well, who's got a definition of refactoring in the room? Yes?
Rewrite the test, and then you run it, and then it fails, and then you rewrite the code.
Almost. So refactoring is making a change to the implementation of your application without changing its behavior. All right? So if you're messing around in your code and you're like, right, well, I'm going to change the way this class works and the function and stuff, and I'm also going to slightly change its return, like, that's not refactoring. Like refactoring is keeping things exactly the same, but just changing the implementation. So when you're refactoring, you don't change your tests. And so there's another thing which is like in refactoring, what we do is we run our tests, we see them all pass. And then we go and make changes to the code, like make it more cleanly organized or make it look nicer or use a slightly different implementation so that we're happier with it. And then we rerun the tests and check they still all pass. So you need passing tests to do refactoring. And if you don't have tests, you're not refactoring, you're just messing about. Okay? And so at this point, we've met the sort of testing goat, and it's this point that I like to introduce refactoring cat. Has anyone ever met refactoring cat? Let's see if we can go and find him. He's in Dropbox somewhere. Refactoring. Shoop. Come on, refactoring cat. You know you're in here somewhere. Shoop. All right. Refactoring cat. Here it is. Refactoring cat. This is what happens when you're just refactoring without some... All right, no, okay, look, I'm fine. I'll just change this little thing over here, and then maybe that just depends on it. And then I've got this, oh, no, God, oh, nothing works. Oh, fuck, where am I going? Oh, no, all right. Right, no, fine, okay. Just going to change some code here, and then I'm just going to make a little... That's all. I don't know. This is refactoring without tests, right? When you have tests, then there's no need to be sliding around in the bus. So like, remember, you should obey the testing goat. Have tests. Go step by step. Don't end up like refactoring cat. Okay? Should I just leave this slide on for like the rest of the training? That would just be better, wouldn't it? Cool. So we've got all our... so let's do a bit of refactoring then. So what's the first thing we do with refactoring? You're probably like starting to get the hang of this now. We run the tests. All right, fine. We've got our unit test. It passes. So that allows us to start changing the implementation. So let's say, okay, instead of returning this HTML like this, I'm going to have it in a template file. So I'm going to go mkdir super. So templates live in a folder called templates inside each one of your application's views. So we're on to-dos, super lists, templates. Cool. To-do, super list, templates, home.html. Paste. All right. So then I can start taking my HTML and making it a little bit neater and tidier like this. All right, fine. So that looks good. He's unhappy that, yeah, okay, whatever, shut up. So I'm going to make a file called home.html, and now instead of having my HTML in an ugly string and it's all green, well, now it's all blue and purple. Much nicer, right? So I know I haven't made any syntax errors in my HTML. Good, that's there. Just to make sure that nothing's broken. Right, test still passed. Good. So we go back into our views and we say, all right, well, rather than returning this HTTP response with all this text, let's return the template. So I'm going to go return render. And the way render works is it takes the request for secret reasons from the future. And then we give it the name of the template, which is home.html. And then what Django will do is it will go through all of your apps. Oh, sorry about that. It will go through all of your apps, look for the templates folders, and it will find one called home.html. And the first one it finds, it's going to render that and transform that into an HTTP response and send it to the browser. Sound good? Cool. What? Sorry.
Is there a command in Django to automatically generate sort of that templates folder structure?
I don't believe so, no.
Okay, so
No. I'm afraid so, yep. You can actually store your templates wherever you like. You can go into settings.py and say, oh, actually, I'm going to store them, in some crazy place. But by default, like Django will go and find templates in your apps. And actually, this is quite relevant. So I'm going to run this and see if it passes. And, oh, what? Okay, we've got another traceback, right? We'll do our little rules. Is it the right test? Yep, sure enough, I can check it's the right test. Now go and look at the error, and it's saying template does not exist. Does not exist home.html. What's going on? Like it's called home.html, and like it's right there. I put it in. I don't know if you can see that, but anyway, I put it in list templates home.html. It's right there, and like I ran start app, so Django knows that there's an app called list. No, it doesn't. Right? It's not enough in Django to run start app and make Django start your app for you. But if you want Django to really truly believe that you've got an app called lists, you need to add it to settings.py to installed apps. So this is the only other thing we need to do. We need to go into settings. And notice here that our tests have actually saved us from making a mistake. And so we go and find installed apps, which is, where is that? Here we are. Hop. So in settings.py, which is the global settings for your whole project, you tell Django, actually, I really mean it. I said start app lists, and I actually really mean it. Let's add it to the project. And you add it in here as a string. So that goes lists. Oop. Choop. All right. So I put that in install apps in settings.py, and we rerun that. And then we get this slightly unexpected failure. Oh, what? But at least it's found the template, so we've made progress, right? So what's going on here? And it's saying, oh, response.content, so it's saying it no longer ends with HTML. What's going on there? It sure looks like it does. What's happened there is that my text editor has added a new line. So it used to have HTML, and I've actually got HTML new line, right? So it's just a very subtle thing, but I could just go and check that over here. So if I go into my tests, I'm going to do this over here. So sometimes when you get an unexpected failure like this, where you're not too sure what's going on, like why is this suddenly not working? A little bit of print-based debugging is absolutely fine. So we'll do response.content. All right. So I rerun that, and now I'll see like it's going to print out my content. So the HTML is there, and you see there's this new little bit of white space there, and then I've got my title, a new bit of white space, HTML, and it ends in HTML backend. So when I switch to using a template, it added that new line. So I can say, all right, fine. The intention of my test is still the same. I'm pretty happy that if I just say go.strip in here, which will strip any trailing white space, that's still the same test. Rerun it, done. Fine. So that's refactoring. My test made sure that everything still worked exactly the way it did before afterwards when we finished refactoring. So that's refactoring. We got there. You may not see that whole problem with the back end, depending on what your text editor likes to do with line endings. I'd like you guys all to do that. And then once you get to the end of it, you can rerun your functional test to check that everything really still works. And if you feel like you can start editing home.html and adding, say, the H1. So we've got that. Hub, OK, H1, to do lists. Yep. Yep. Usually it's better to use find elements. Usually. Cool. All right. fine. Da-da-da-da-da-da. Okay, so we've done our little bit of refactoring, right? So now we've refactored our view function. You can also refactor tests. And the thing is that our tests are pretty ugly as well. If I go and have a look back here at this list.tests, like in real life, you're unlikely to write some tests like this that check that like angle brackets HTML is in blah, blah, blah. So really, like our test here should probably be checking like what's important about the home page is not so much now that it returns particular bits of HTML. What we're just saying is like, I want the home page to render the home template. So we can sort of say, rather than saying test home page returns correct HTML, we can slightly transform this test and so we can say test home page uses home template, right? And so now rather than comparing all bytes, what we could do is just say, okay, well, I want to test that rather than comparing like a number of little bits of strings, I just want a test that says, is the home page using the home template? And one way of doing that is, why don't I, the test, manually fetch and render the home template, and then compare that to what the view gives me, and if the two are the same, then I'm comfortable that it's used the right thing. And so the way I can do that is I can go from django.template.loader import render, is it render to string? Okay. So I can actually, in the test, go expected HTML equals render to string, home.html. And then I can do self.assert equal. Response.content, and I'm going to make a deliberate mistake here. Expected HTML. All right. So does that make sense? So like basically, rather than checking all these strings, I'm going to delete these bits later. I'm going to say, all right, well, let's fetch the home let's fetch the home template, render it ourselves, and then see if the view is doing that job as well. Oops, wrong tests. 1, 2, 3, good. You notice that the functional tests take 3 seconds to fail now. That's the implicitly wait kicking in there. All right, fine. So what's this saying? Like it said, all right, is my response content the same as the expected HTML? Now, if you guys can decode this traceback, what it's saying is, like this not equals this. They look very similar, and the difference is this little B symbol. All right, and this is a Python 3 thing. Like in Python 3, there's an important difference between bytes. Bytes are ones and zeros that you can put on a disk, or you can send over the internet, or you can receive from the internet, or you can read from a disk, right? But to transform those into a string, which is a magical Python object that Python understands and that can be manipulated in various ways, you take a string which is ones and zeros and you decode it into a Python string. And so here I was trying to compare a string with some bytes. And so Python will tell you, look, the string, the representation of a string, which is some bytes, is not the same as the string itself. So the map is not the territory, or some sufficiently deep analogy that I can't quite deliver there. So what we do to transform bytes into a string is, we make sure we don't have caps lock pressed, and then, what the heck? Okay. Oh, come on, you. There we go. What we do to transform a string is we do decode like this. So .decode takes some bytes, decodes them because bytes are encoded as ASCII or as UTF-8, and it transforms them to a string, which is a magical Python object. And then if I wanted to take a string and encode it, I can go string.encode, and then I can even specify I want to encode it as UTF-8, or I want to encode it as ASCII, or I want to encode it as Latin 1, or whatever you might have. So that's our little bit there about Python 3 and Unicode and whatnot. Ta-da! So that works. Good. We can delete them. Yeah. And then we manage our tests. And so now we've refactored our tests as well. Question over there. What is the default encoding is the question there. So the default encoding comes from your system. So Python tends to look at what its operating system's default is, and it tends to use that. I think I'm glossing over a lot of complexity there. There are clever ways of making Python use a different encoding and blah, blah, blah. So what Python 3 does is it kind of forces you to know. You can sort of, when you do .decode, it'll just magically use the system one. If that happens to be the same thing that you use to write the file home.html, everything works. And then when things break, you go, oh, hang on, I need to actually know what the correct encoding is. And so there's, like if I did over here, rather than just calling decode, you can specify what encoding, and I believe I'm working in UTF-8, but since it's got no complicated characters, that will still work. So, but then I could put like, if I was working in, what's it called, ISO 80096. You could do that, UTF-8, you can use ASCII, you can use clever Russian encodings. There's, what's the evil one with a P in it that's not even using the same number of bits? Anyway, anything you like. Good. All right, so let's assume we've done that. The next thing we want to do is like move a little bit forward. So we've got our template rendering now. We can start to make changes to our template. Our functional test is failing and saying, right, I need to have an input box that I can type some keys into, and I expect to be able to see my inputs in a sort of table. So let's start building that out a bit. So I'm going to start that. Well, I'm going to have maybe an input in here. ID equals ID, new item, shrink. Okay, so we'll do that. All right, and then we'll go Python 3 functional test. Okay, fine. So it finds the thing, and it's expected. So our input is saying, oh no, the placeholder doesn't work. It wants a placeholder to say enter a to-do item, but it doesn't. So we'll go and do that. All right, fine. Placeholder equals enter a to. Who remembers whether it was capitalized or not? Yeah, okay, like that. So we'll try that. Python 3 functional test. What have we got now? No, it wasn't. Isn't that nice, by the way? Look at that traceback. Like, this is Python 3 unit test stuff. Like, when you compare two strings, it gives you like a clever diff output that points out exactly what's wrong. This is one of the good reasons to use unit test. Python 3 functional test. What have we got now? Okay, it can't find the ID list table, so we'll put that in here. Table ID equals ID list table, and we'll go like end table. Okay, fine. Right. Python 3 functional test.py. And so this is all going to work fine. Okay, to do this. Oh, look, you can see it actually typing a thing in, and then it goes, right, well, false is not true. It can't find 1 by peacock feathers for row and rows. Like, this error message is a bit crap, isn't it? Like, you remember early on when we had just assertion error? This is like no better, is it? It'd be nice if it said, rather than just saying false is not true, if it nice actually told us what the tables and table rows were. And this, when I was writing the book, this is where the moment at which you realize that actually, earlier on when I was feeling really clever with my with my any function, like if I take another look at this sort of assert true, wouldn't it be just quite a lot simpler to sort of write that like just as an assert in, and if I had that sort of row, like I could just maybe just do this, like row.text for row in rows, and maybe that's actually shorter to write and it's easier to read, and it's going to give me a better error message. And when I was thinking, wow, I'm so smart, I've used the any function, isn't that cool? I wasn't being smart, I was being like overcomplicated. So if you ever have that smug feeling when you're writing code, just check yourself and make sure you're not just making things more complicated than they need to be. All right, so we'll write that, and hopefully it'll give us a slightly better error message, which is going to say, so there are no rows in our table. How do we start adding rows to our table? We're actually going to have to process the user's input. So how do we do that? How do we process user input? Anyone? Like, how are we going to send the user's input to the server, and how are we going to, anyone? I'm looking for the word post. Oh yeah, we'll send a post request. That's what you were about to say, wasn't it, sir? Yeah. That's absolutely right. So we can we can start wiring it up a little bit. And so this is a good question, actually. So what should you write tests for, and what shouldn't you write tests for? This is a rule of, so obviously, rule number 0 is test absolutely everything, okay? And so rule number 1 is, okay, well, not absolutely everything. Don't test constants is the rule. So it goes like this. Like, if you've got a bit of code that says wibble equals 3, there's no point in a test that says assert wibble equals 3. There's no real point in tests that just duplicate the implementation of your code line for line, right? You want to test behavior. You want to test the way or the effect of things, or what things do, not what they are. And so similarly, a template, this HTML template, this is more or less, like this is a constant, right? So I don't want to particularly test the contents of a template. So if I'm just adding stuff to this, I don't particularly need to write tests for it. To wire up the form, I can just go, okay, well, we'll add a form, and we'll go method equals post, fine, and pop that there. We'll go end form, fine. And then this thing, in a form, input should have name, so this is going to be item text. Okay. And so in general, you don't test much in your templates. Once we start having logic in the templates, once it starts to have ifs and fors and things like that, then we could test it, and I'll demonstrate how you can do that if you want to later on. All right, but so this just like, I changed some constants. Now I've just transformed this input box from being a do-nothing input box into an input box that's going to like post itself to the server. So that's fine, but that's still not going to do anything until I wire up the server to understand post requests, and I get this. Can you see that? Oop, bang! I'll do it again. Okay, great. I've got both windows over there now. That's not what I want. So yeah, you should see this. Oh, CSRF token verification failed. Now, does anybody know what a CSRF exploit is? Can you explain it to the class? Yep. Yeah. Right. So typically, the way it works is like, if I can convince you to come to my website, I can put some JavaScript on there that's going to send like some AJAX post requests to any website I like. And so maybe like, because I can make your browser do things, I can make your browser, which is you, with your cookies, like do some requests to a different website, and like say maybe I could send a post request to the to-do list app saying, aha, enter a to-do list saying I smell. And because you're logged in as you, it would be authenticated. And even though you visited my website, but I've made you send things to a different website. And so the defense against that is to have every single like form and every single request that you build on your own website like identified somehow, so that when someone sends you a request, you're quite sure that it could only have come from you. And the way we do that is we put like a little secret token that we only put on our web pages that only users of our website can see if they're logged in. So an attacker on a third-party website, they might still be able to send the post request, but they can't guess what the little secret token was. This is quite a cool thing. When I studied security at university, I did my degree quite recently in computer science, and I did security out of a sort of feeling of duty. And like I thought it was going to be kind of dry and boring, but I thought, well, you have to do it, it's like responsible. I was so wrong. Like security was one of the most fascinating topics. It's all about hacking, and it's all about like exploiting systems and making them do things they weren't supposed to. Like there's this brilliant bit where Bruce Schneier goes, you've got the security mindset. Like I was a child, I used to be able to buy these like ants. You used to buy an ant farm in a shop, right? But the farm in the shop didn't have any ants in it because they would die or whatever. So instead you bought the ant farm, and like with the ant farm in the box came a little card, and if you put your name and address on the card, they would post you the ants, and then you would get them in the post. And like my friend, we bought one together, my friend said, oh wow, that's amazing, I can't believe they send live ants through the post. And I said to him, yeah, I can't believe they send live ants to the post to any address you specify on a piece of paper. So yeah, that kind of thing. And so if you guys are interested, if you want to find out a bit of that joy, I recommend a textbook by a man called Ross Anderson, who's a lecturer at Cambridge. Wrote a textbook called Security Engineering, which when it arrived in the post, I was like, oh no. It's this thick, right? It is this thick. It's like 1,600 pages, and it's an absolute page turner. I started reading it, I was like, oh, this is so cool. And it's got sort of Saudi fighter jets being diverted using RayPlayer text, and it's got like a whole chapter on like doors and lock picking, and it's got a whole thing on forging banknotes, and it's got a thing about like long distance lorry drivers who have tachymeters to make sure they take regular breaks, but they want to fiddle it in order to get better pay. So they use like electric drills to fiddle the tachymeter, and then there would be like countermeasures against that. And there was like a whole chapter on, like why you should have a dog, which is better than locking the door at night. And, like fascinating stuff. So I could strongly recommend Security Engineering by Ross Anderson. So CSRF token, yeah, we found that out. Okay, fine. All we need to do for that magic is we put CSRF token in like this. And this is the first time that we've ever used the Django template syntax. And the Django, suddenly this is not HTML, this is special Django stuff. right? And so because Django is rendering this template, it can replace that with a secret magical template. And notice that it uses this, this syntax curly bracket %, which is patented as the world's hardest two-finger touch typing combination. Just try it, like left pinky finger to right pinky finger, open curly, then right pinky finger shift, left pinky finger up to the number 5 to hit the %, and then space. Like, it breaks your fingers and you get it wrong every time, and I hate those guys. Why would they do that? So we pop that in, and then maybe we'll see, next time we run it, it won't have the CSRF failure. But instead, there's no CSRF failure, but we've sent that thing to the server. The server's just totally ignored it, so it's still not working. We need to actually wire up our view to accept post requests. So how do we do that? Gentleman at the back is correct. Now we write a test. So everything from now has just been constants. We can go back into our tests. We can write a new test, like a second test, that says test home page can handle post request. Self. Okay, so we do something very similar to the last test, to yank yank. We create a app, but instead of just having a normal request, we can set the request.method to be equal to post. Hup. Oops. Fine. And then we can actually send some post data. So, never live code anything ever. And certainly don't make your entire tutorial dependent on it. Okay. So you notice that the name parameter here in our HTML is what will map to the dictionary of the post here. So if you go hup, 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 shoop, pew, jump, equals a new item text. Or let's call it a new item. Fine. Shit. And then what we want to say is, basically, we want somehow our view to take the user's input and then stuff it back into the template when they send it back to them, right? So what we're going to do is we're going to say assert in a new item, and that should be in our response.content.decode. All right, does that make sense? We create a request. This time we make it a post request. We say, like, post requests have key value pairs. They're like, say, so each input on your form has got a little name, and then the value, which is what the user's typed in, will become, so that's a little dictionary, like the post dictionary. And then we call our homepage function with that request, and we say, in the response, we expect the view to have put that new item. Okay, fine, let's try that. And I'll let you guys all catch up in a minute. Manage.pytest. Fine. Okay, a new item is not found in all of that. So how do we get that test to pass? We go to views, and then we go, oh, well, okay, so if we go a new item equals request.post. So let's pull that out of the request.post. So we do that like this. Text. And then what we want to do is we want to sort of pass it into the template somehow. So how could we put, well, like what we can do is we can do this. Like, what if it's a post, we're going to do that. Double equals post. Well, then what we can do is, rather than just returning the normal template, we can just return the HTTP response. And so this is like the stupidest way of getting this to pass, right? So new item. Fine, great, okay, very smart. I've built a view that takes a post request and just, okay, so that's not really what I want, is it? What I want is for the view to actually put that new item text into the table in the template, right? So let's adjust our template so that it can actually have some new item text in it. So where's my table gone? Table equals ID. What's this called? List table. And then we can pop it like this. Say new item text. All right, fine. So we've seen the first syntax for like sort of adding magical Django stuff. The second one is this, new item text. So what this is saying to Django is like, I expect this template to be rendered with like a variable called new item text, and I'm going to print it into the template at that point. Let's put it into a table row so it's proper. TR, TD, NTD, NTR, all right, fine. Oop. Okay, that looks fine. Okay. So then in our test, instead of saying, okay, well, yeah, we want that to be the case, but what we also want to do is something a bit like this. So we want our view to use the SEM template, but we want it to pass in this sort of new item text and show it in the template. So the way that's going to work is we pass in a context like this, which is a dictionary, new item text, shink, is a new item. All right. Fantastic. So now, so let's make sure that we understand this. So what am I saying here? I've got my home page template over here, and it's saying, all right, render me and give me a new item text. I'm going to put it in the table, all right? And so in the tests, I'm going to say, all right, let's say that we're going to make an expected HTML, which is going to take the home page template, manually give it a new item text like that, and we expect that our view should be doing this job. All right, so we're saying not only should a new item be in there, but it should also still be the template, the same template. That's what I'm saying. Question? Sorry? Yeah. So that's not calling the function. I'm not sure if you can quite see that. That's populating the dictionary. So a request object, this is how Django represents requests. And so first of all, it has the attribute, like, is it a post, is it a get, is it something else? And second of all, requests that are posts also have a post dictionary attribute, which is the contents of the post. But you could make a get request that has a post. That would be a broken type of request, but it is theoretically possible. So we're reconstructing the kind of request the user would send it. Good? Good question. All right, fine. So let's see what happens if we run that test. New item is not there. Okay, and so now we can change our view to actually, rather than just returning a brand new item, we're going to say, okay, fine, let's actually send it to the template. So we do like this, new item text is going to be new item. Fine, shunk, shunk. All right, ship. We'll try that. Fantastic. And now we've got this oh, no, I haven't quite got that right. Yes, okay. All right, so I rerun my tests. And now look what's happened here. The first test actually passed. This is the important thing. Like when you look at a test failure, you need to check which test is failing. So this is actually the original test is failing now. So my new test passes. My post request is working. That's all good. But the old way is not working. It's saying, oh, the home page template, this is the old test, home page. And the error is saying, local variable new item reference before assignment. And what I've done there is, like in my haste to get the post situation working, I've made a thing that's so if the request method is not post, this is going to come through here and have new item be an unassigned variable, isn't it? So that's quite nice. So basically, I've been making some changes to my view, and the old test has actually told me that I accidentally broke something as I was going. So this is one of the other great points of testing, is that it helps you from making stupid accidental mistakes like that. So I can just do this. Item. All right, fine. And that passes. So we say, okay, if we're a post, then we'll have a new item, which we get from the post dictionary. And if we're not a post, we'll just put nothing, and then we'll send that new item to the home page template. The home page template is going to render it. It's going to put it into the table row. So my table is now going to have whatever the user typed in is going to be in there. This is all magic. With a bit of luck, my functional tests are going to pass. Okay, let's have a look. Do they get any further? Wow. Or one by peacock feathers, not found in by peacock feathers. Thank goodness for my new assert in method, which was less smart but much more useful. And we just need that little 1 colon. All right, let's hack that in quickly. 1 colon, fine, zap, Python 3 functional test.py. Let's have a look. Here we go. Oh my God, finish the test. All right, we got that far. Fantastic. We have now actually built a to-do list app. And if you actually do finish the test, you've built a to-do list app that can have exactly one item on its to-do list. But that is still progress, people. That is still progress, and no one can take it away from us. Or at least no one can take it away from me, and pretty soon you guys are going to code it, and then no one will be able to take it away from you. Go! Are there any questions before you dive into that? Yes?
Testing what the render of Django is doing. Is it kind of testing render against render?
Yeah, which is okay. I mean, the alternative, what else would you do, right? So later on in the the question there is aren't you sort of you're using render in the real thing, and then you're using render in the test, and is that sort of testing render against render? And it is, but we know render works. So the important thing is for that to pass, the implementation must be correct. So it must be using the template in the right way. But it is a bit clunky, you're right. And so later on in the book, which I don't know if I've mentioned, but I'm writing a book all about this. Later on in the book, we use a cleverer thing. So Django has some helper methods that will say, rather than having to, there's a method in Django called assert template used. And you can use that to just say, oh, did it use home.html? And that happens a bit later in the book. I like to show the manual way first so that you understand the mechanics of it before showing the magic way. Good question. At the back there was a question. Hello. I'm looking at you, sir. You put your hand up, totally. Oh, okay. Why, what, did I answer it? Or did... Okay. You sure no one else would love to hear the question of yours? Because you get a prize. Yeah. Okay, in the functional test or in the... Yeah. All right, let's take a look. La 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 la. All right. Is it this one? All right. So yeah, just for anyone that hasn't got this, what's going on here? We're checking for the string by peacock feathers. And what are we checking for it in? Well, we go through each of the rows. This is a list comprehension. And it says the text of each row for all the rows in our little table rows. So it's saying at least one of those, at least one of those table rows must be that. Good. All right, so I'll let you get on with that. And then we can start writing a little bit more of the FT here and have the thing where she enters a second item and it won't work. Question?
I was just wondering, does what you were describing before with the Django method of testing, does that kind of mirror the mock module?
Yeah, so behind the scenes, Django is doing some clever stuff to sort of put little watchers on the view functions and it'll be able to tell you what template was used. Yeah, it's because there's some Django magic, which is a lot like what would happen in mock. And an alternative way of doing it would be to mock out the regular function, but it's uglier. So yeah. Okay. 3 strikes and refactor. In the handout, get down to where it says 3 strikes and refactor, which should show you should get to this error message. So basically, it's the point in the test where we realize that we actually only have one possible item in the list, and we're going to need to do something cleverer. Questions? All right. Okay. Well, everyone, we're out of time. So that's fantastic. We've made it through the first 4 chapters of my book and all the way into chapter 5. I don't know if I mentioned this, but yeah. So we made it into chapter 5. We got as far as a to-do list that can handle having one item at all. If you follow through the rest of the book, we go step by step to making a to-do list that can handle multiple items. Although, it's multiple items that everybody on Earth shares because there's only one global to-do list. And in a way, that's nice, isn't it? Because it sort of reminds us that, as a planet, as a race, the human race, we all do face the same global to-do list. We have the same challenges that face us as a civilization. On our little blue spaceship cruising through the empty, black, terrifying void of intergalactic space. But the thing is that it's not actually that useful as a to-do list. So then in chapter 6, we make it so that everybody can have different to-do lists. And in chapter 7, we add CSS and Bootstrap. And chapter 8 has deployment to a real server with Nginx and GUnicorn and UWSGI, and automate the deployment using Fabric scripts. And then we have chapter 9's got forms and advanced forms and validation. And then we get into JavaScript. The JavaScript. We use some JavaScript unit testing. That's all in there. And then we get into the third part, which is all cool topics like integrating third-party authentication systems, AJAX, post requests, mocking. We get into the Persona browser ID system, and we get into using continuous integration and debugging on the server and logging and outside-in TDD with methodical step-by-step ways of going through your test isolation. Why is that a good idea? And we even use continuous integration and setting up Jenkins to run our tests for us overnight and stuff. And then by the end of the book, you're a serious testing beginner intermediate like I am. So that's all there. I encourage you to take a look at it. Like I say, if you do a tutorial, it's great. You learn a bit of stuff, but you will forget it all. So if you want to sort of nail all this stuff down, carry on and do a bit of practice outside of this, and then you can take it on into your own projects and maybe start doing it. So here we are. I realize it is properly lunchtime. Are there any questions that are absolutely burning at the moment? Yes? Yeah. Yes. Good question. So normally in a continuous integration server, after a while, if you build a lot of functional tests, they take a long time to run, right? Because they click through your website manually and blah, blah, blah. So you want to devote that task to a server that's just going to run it every hour or whatever and just email you if you've broken something accidentally. But it doesn't have a screen, right? If you run things on a server, they don't have a display. There's a thing, so the solution to that typically is XVFB. It stands for X Virtual Frame Buffer. And what it is some software on the server that will just pretend to have a screen, and Firefox will run secretly, silently, thinking it's got a screen, but it doesn't. And then if anything goes wrong, you can make it so it takes a screenshot and saves it to the disk for you, so you can go and take a look at the screenshot and see what happened. And it's actually quite a useful thing on your own machine. If you're running tests, you can use XVFB as well if you're on Linux. And then your tests, rather than popping out windows everywhere and annoying you, will just run quietly. So XVFB is the answer there. Did you say you had a second question? Yeah. You're the same? You're not retrieving the same? Right, absolutely. So in chapter 7, in which we deploy to a server, the whole point of deploying to a server is we make a staging server where we're going to go and run the tests and make sure we can deploy it correctly before we deploy to the live server. And we can hack the functional test runner so that it runs against the server instead of running against locally. And that's absolutely a topic. And then similarly, when you run your functional tests, they're going to reset the database in between each test. You need a way of resetting the database on the staging server, and I demonstrate ways of doing that. So that and many more topics are covered in a book which I'm writing. I'm not sure I've mentioned it. So you should check that out. Yes, thank you. Any more? Yes?
Can WebDriver run on Internet Explorer?
Yes, WebDriver can absolutely run Internet Explorer. You can use WebDriver to run tests with Chrome, with Firefox, with Internet Explorer, with Safari, and it even will run and emulate mobile browsers and mobile operating systems. Yes?
A question about that. Does it come with the drivers, or do you have to
So in the case of Firefox, it's built in, and some of the others it's built in, and some, for Chrome, for example, you have to download a little extra executable. So for most of them, it just works. For others, there's sort of plugins that you need to add to your browser. Yeah. Guys, wow. Oh, wait, there is a question. Yes?
This has been great. Is there a book where I can learn more
If so, is there a discount coupon?
Yeah, I should say that. Anybody that wants like a little discount coupon, come and fetch them. Thank you very much, guys. You've been absolutely wonderful. There you go. So I really should say this. Like you have to like fill in the feedback forms. Like that is so important. So where's it going to be? Like PyCon feedback. Oh, whatever, I'll post a class note. You're all still on the mailing list for that. Please fill in the feedback form. Tell me how I can improve this. Tell me that I suck, if in fact I do, which I suspect is the case. Then, PyCon can not invite me back, and so something else better will be in my place, or not. And just in general, like for the organizers that run these things, it's really, really helpful to have the feedback and to know whether people thought it was good or too slow or too fast. So it's not just helping me improve, but it's also helping the conference. So please fill in that feedback form, and thank you all very much for being absolutely wonderful, and I'll see you around. If you want to ask questions of me all week, I'm around. Come and fetch a little discount code anytime in the week. I've got a book signing, apparently, which is ridiculous. Like, what? Who? Me? So there's a book signing, so if you come along, you get a free copy of the book, like free. You don't even have to have a discounted one, 40% off, by the way. And see you all around. Thanks again. Woohoo!
When is the book signing and where?